Welcome to section 4.4, the geometric distribution. This is our second specific discrete probability distribution that we're going to talk about in this class. All right, so let's talk about an experiment to introduce a geometric distribution. So let's suppose you want to know the probability of getting your first 3 on your 5th roll. So you're rolling a dice, you roll, and you don't get a 3 until the 5th roll. So you get not a 3, not a 3, not a 3, not a 3, and then you finally get a 3. The probability for each of the first 4 rolls to not be a 3 is 5 out of 6. So that's a probability of failure. You failed 5 out of 6 times. You didn't get that 3. The probability of getting a 3 on the 5th roll is 1 out of 6. So if we look at the probability of getting a 3 on those 5 rolls, remember these are independent. The probabilities of what you get on the first roll doesn't affect what you got in the second roll, etc. So we can multiply these probabilities together. So this is the probability of not 3 on the first roll, not 3 on the second roll, not 3 on the third roll, not 3 on the fourth roll, but finally getting a 3 on the 5th roll. Multiply those guys all together and you get about 0.0804. This is a geometric experiment. So there are 3 main characteristics of a geometric experiment. There are 1 or more trials, sort of like a binomial, but in this one is going to be failure, 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 failure until you finally succeed. In other words, you keep going until you get your first success and then you stop. So if we are throwing a dart at a bullseye, maybe we try, it takes us 6 tries to hit the bullseye. So the trials are fail, throw, fail, 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 success, and then we stop. Okay? So that's the way a geometric distribution works. A couple more characteristics. Number 2, in theory, the number of trials could go on forever. You would just keep failing. There has to be at least one, though. And the probability P of success and the probability of Q for failure need to be the same for every trial. It can't change from trial 1 to trial 2, right? They need to be the same. As always, they add up to 1 because they're complements, and Q is going to be 1 minus P. Let's do an example. We're going to play a game of chance that you either win or lose. There are no other possibilities. We're going to play that game until you win. Your probability of winning is 57% or 0.57. What is the probability that it takes 5 games until you win? And that means exactly 5 games. So that means lose, 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 win. So we're going to let X, a random variable, be the number of games you play until you win. And that's always going to be what we have X be for the geometric distribution. So this does include the winning game in our X. So X can take on the values 1, you could win the first time, 2, you could lose the first time, win the second time, 3, lose, lose, win, etc., etc. In theory, you could keep losing forever, right? The probability that X is exactly 5 is going to be a lose, 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 win, right? And that's 0.0195. We multiply all those probabilities together. And again, each trial is independent, so that's why we're able to just multiply those guys together. Let's do one more example talking about mean and a little bit about standard deviation. We're not going to be using those too much. Mean, we will. Standard deviation, not too much right now. The lifetime risk of developing pancreatic cancer is about 1 in 78. So, and that is equal to about 1.28%. Let X equal the number of people you ask until one says he or she has pancreatic cancer. Then X is a discrete random variable with a geometric distribution, right? Success would be they had the pancreatic cancer. And again, this is success in a statistical sense, not like success as we use in the English language. So a success would be finally you get someone that says, yes, they've had it. So this is a discrete random variable with a geometric distribution. And we would say X is the distribution geometric with this probability of success. What is the average number of people you must ask? Again, as I told you in the Excel, and here's another note, the mean of the geometric distribution, so this is the mean, the expected value, the average number of people you should ask, right? It's going to be 1 over the probability of success. 1 over 1 in 78, 78 people. And that makes really good sense that you expect to ask 78 people before you get a success. And the standard deviation is equal to the probability of failure divided by the probability of success squared, square rooted, because we always square root for standard deviation. Plugging that in, it would be 77 in 78 over 1 in 78 squared. Plug that all into your calculator, take the square root, and you get about 77.5. Just kind of a FYI, how do you calculate standard deviation for the geometric probability distribution? All right, that's it for this one.